Okay. All right. So I am going to be going over the deadlock detection algorithm. Okay. So how this works is for the extra credit tomorrow, you might get deadlock detection or you might get bankers. And whichever one you don't get, that will be on your exam. So if you get deadlock detection on the extra credit, then you're going to get bankers on the exam and vice versa, okay? I'm going to show you deadlock detection, and you should be good to go, okay? This is the same one as your practice exam, and if we really need to, I can give you another one. But yeah, so let's go ahead and start. First off, there's a few things you need to know, such as R is equal to V plus A. And this formula is a universal formula for deadlock detection. And essentially, it's saying the available matrix, or the available matrix plus the allocation matrix is equal to the resource matrix. So, the resource matrix. So, basically, when doing the math before we start, you got to understand that this is all in context of like processes. So, like, you know, if what's available is 110 and we're requesting 110, then that will work, right? But if we have 110 and we're requesting like 550, it's not going to work. You know what I'm saying? Like, it's not, because we're requesting resources that we don't have available. And that'll make sense in context when we actually solve the problem. So, first off, the question is going to ask you, usually it's going to start by asking you, what is R? It's going to ask you, what is R? Okay. And to get R, you just follow this formula. You say it's V plus A. So you take V, and also, if they ask you for R, they're going to give you V. If they give you R, they're going to ask you for V. And I hope you can rearrange this to solve for V. But it's either one or the other. They might give you R, and then you need to solve for V, or they need to give you V and you need to solve for R. But let's say we want to find R, then all you do is V plus A. So you take the 1 and the 1 and the 1, and then you just go to your A, and this will all be given to you. The Q will be given to you, the A will be given to you, and you just add the columns. So we see that R is equal to 1 plus 1 plus 1, so 3, and then 1 plus 1 plus 1 plus 1, and 4, and then 0 plus 1 plus 1, which is 2. Okay, so that's how we find R. And you know you did it right if the numbers are all unique. And what I mean by that is that if 3 and 4 and 2, you shouldn't have any repeat numbers. So if you have 3, 3, 2, or 3, 4, 4, or 2, 2, 3, or whatever, that's wrong. You did it wrong somehow. So, make sure you know that. Okay, so that's the first part of the question. It's going to ask you, okay, what is R? And the second part of the question is going to ask you for, it might ask you for W, but we'll worry about that later. We're going to figure out what is the processes that are deadlocked. Okay, what is deadlocked in this process matrix? So all you got to do is your Q here is known as your request. So this is what your CPU or your operating system or whatever is requesting. It's requesting each row by row, okay? And we can label these rows. We can label this process 1, process 2, process 3, process 4, and process 5. Okay, and the relation is the same respective to A. So, if the first row is process 1 and in Q, the first row is going to be process 1 in A, okay? So process 1, process 2, process 3, process 4, and process 5. Okay? So how do we determine which of these processes are deadlocked? All you got to do is you take what is available and you compare it to what is being requested. Okay? So if the computer is asking, hey, we need something, and it's going to need 110, Then we do 1, 1, 0, and we check, is this less than or equal to how much resources we have available? In our case, it's the v vector. So we check, is that less than or equal to 1, 1, 0? Okay? And it is. This passes. So this is not deadlocked. It can't be deadlocked, okay, because this passed. Now, what we do is we take the corresponding process and we take the cost. So this is saying, hey, we're going to need this, but this is kind of how much it's actually going to be, like, we can add back to our v vector, okay? So our v is now going to equal our original v, and then plus the respective process for our a. So 0, 1, 0. So our new v is 1, 2, 0. Okay? And we can now mark P1 as safe. Okay? So we're done. We don't even have to think about it anymore. We can cross it out if you want. Okay? Safe. Now, we can go back and we can look at P2. P2 is requesting a 0, a 1, and another 0. And we have our brand new v here. So we do a 0, 1, 0. Is that less than or equal to our new v of 1, 2, 0? We see that it is. Okay. So we can go ahead and check this, and we could say, all right, this is safe. And now we need to update our v. And we update our v using the A matrix. Okay. So now we have 2, 2, and 0. Okay. So, you know, there's a lot of ways you can look at this. Mathematically, it's just very basic addition. But conceptually, your Q is the only thing. Their Q is like your reference, right? This is just what you're looking at. And your A is actually going to be modifying your V. So there's a relationship between A and V, but there's no relationship between Q and V. Okay, so Q is just, you're just looking at it, you're using that to get your data, and A is actually what you're using to modify your data. So now let's take a look here. We have 1, 0, 1, and we can go and we can compare, is 1, 0, 1 less than or equal to our brand new V of 2, 2, 0. And I'm just going to erase it, and I'm going to move it down here. 2, 2, 0. So is 1, 0, 1 less than or equal to 2, 2, 0? Well, we can see 1 is less than or equal to 2. 0 is less than or equal to 2, but 1 is not less than or equal to 0. So therefore, this is currently deadlocked. And notice how I said currently. Currently deadlocked. Okay. And the reason we say currently deadlocked is because we will go back to this process eventually and check, is it still deadlocked? Because what could be happening is that, you know, one thing is being used, and then I guess that's like a terrible drawing, but like, let's just say like maybe our V gets updated later on, and we can come back and it will meet this criteria. You know what I'm saying? So, and I'm going to label this process 1, process 2, process 3. That way we could see a little bit. So process 3 is currently deadlocked. So what I like to do is I like to just like mark it as like an X or something, but we will have to go back to it, okay? That does not mean that that's the answer, is that process 3 is deadlocked. We kind of push it back in like a queue. So we'll move on for now, and we'll see if we can find anything else, and then we'll come back to it, okay? So now I'll look at process 4, which is 1, 1, 1. So process 4, 1, 1, 1, is that less than or equal to our 2, 2, 0? And remember, we don't update. If it's deadlocked, we do not update the V, okay? We leave it. We leave it B. Leave it B for V. So 1, 1, 1, less than or equal to 2, 2, 0. No, it's not. So this is also currently deadlocked. Okay. Currently deadlocked. Now, last but not least, we can go check process 5. Process 5 is asking for 1, 0, 0. Is that less than or equal to 2, 2, 0? Yes, it is. It is less than or equal to 2, 2, 0. So we go ahead and we take whatever process 5 is respective to our A, and we add it to our V. Okay. So now we say our new v is equal to 2, 3, 0. Okay. So now we have our brand new v, and we can mark this as safe. So we can mark it. We could say this is safe. Put an X. And we're good. But you see, we still have two deadlocked processes here, right? We have two deadlocks. So what do? Do we go back up, or like how does this happen? We still pretend like you're going down again. And I guess you could look at this like a queue where it's process 3, process 4, and it's just getting pushed back each time it gets deadlocked. But what I like to do is just like go back down the same order. So if it's safe, skip it. So safe, safe. Now we go back, P3, okay? That's asking for 1, 0, 1. And we have our brand new V. So P3 is asking for 1, 0, 1. It's less than our brand new V, which is different than the one we compared earlier. And we can see that this is still deadlocked, okay? So we could say that this is still deadlocked. And all we got to do now is we check 4. And we still say this is currently deadlocked. We don't say for sure that's deadlocked because who knows, this might change, So let's go ahead and now check P4, which I believe is 1, 1, 1, is less than or equal to 2, 3, 0. No, that's deadlocked. That's not less than or equal to. Okay. So now that we've gone through all the processes, we've determined our deadlocks, or we've determined what works and what doesn't. We could see that after even going through these two, these are all that's left. They're still deadlocked. We can mark process 3 and process 4 as deadlocked. Okay. And that would be your answer for the second part. Okay. Now, last but not least, it's going to ask you, what is W? It's going to ask you, what is W? All W is your final V. Okay. Final V. So whatever V you ended up with after determining all the deadlocks and all the safes, that's your W. So W is equal to 2, 3, 0. And the same principle applies for Rincon's exams. If you have a V that is like 2, 2, 0 or 3, 3, 0, and there's not an option to put multiple 2s or multiple 3s, you did it wrong and you got to go back. Because it's going to look like this, where you have like little boxes of numbers, right? And you got to drag and drop them in the like place. And I don't think it gives you repeat numbers. So if you have like 2, 2, you only get 1, 2. That means you did something wrong. Okay, that doesn't mean his question's wrong or his answer's wrong. It means you're wrong. Because I have a lot of people ask me that during extra credit. They're like, the answer is like 1, 1, 4, and there's only 1, 1, so he's wrong. No, you're wrong. Okay, so that is your W. And that's it. That's all it is. That's all there is to it. It's not too bad algebraically. It's very simple. It's just kind of remembering what to do. And yeah, any questions?
Cameron, real quick. So you mentioned earlier that the resource vector cannot be repeated. Is that correct?
Yes, correct.
Okay, I actually didn't know that, so I don't know if you want to like kind of clarify it to the audience because I didn't know that as well. Not gonna lie.
Yeah, it's like the same. It's the same principle. I don't know if this is like exclusive to Rincon's exams, but it's gonna be like your R is going to be the same thing. Where when they ask you what R is, it's gonna be like he's gonna give you a 1 or a 2 or a 3 or a 4 or a 5. Okay, and you're gonna drag and drop the numbers. Okay.
I see. Okay,
And
that makes so
yeah,
much
and
more
like
sense.
if
Yeah.
you have like once you've dragged it and moved it to a place, that's it. You can't use it. So if you get 1, 1, 2, he only gives you 1, 1. That there's no repeats. Now I will say you could use that against him, and if somehow I've never seen it on all the exams, but somehow if he gives you 1 and another 1, like he gives you 2 1s, you're probably gonna use both of them. You know what I'm saying? But this isn't like part of the process. It's just that's just a testing tip I'm giving you to double check yourself. So if you get repeat numbers for R or for W, it's not correct probably, unless he gives you multiple repeats. But I've never seen him do that. Okay. Well, there you go. Yeah, that's from the textbook, but yeah, exactly. Like what Liam said. If there's no, yeah, so he sent that exactly. There's no repeat numbers in the choices, so if you have repeat numbers, it's probably incorrect. That's not like a rule. That's just a testing with his exams I see. And it's only because I get people saying, "Hey, I got 112 and there's no 112, like what's wrong?" I'm telling you that. Don't ask us what's wrong. It means you're wrong. Okay. Anything else? Any other questions about this or now I can't tell you if we're getting deadlock tomorrow or if we're getting bankers, but if I'm teaching you deadlock, you might want to make sure you know deadlock. Okay? So, you could be either one. It's 50-50, you know, nobody knows. You might change it last minute, who knows? And by change last minute, I mean could be whatever. But if I'm teaching you deadlock, you can use some sense. Okay. Nobody has any questions? Feel free to unmute and talk and whatever you need to do. Okay. All right. Yeah, I'm not going to go over bankers. I'm going to have someone else, Alexander, go over bankers. Okay. All right. Yeah, I'll post the recording for this. Yeah, I'll post it. I'll stop it and then do another recording, and while that one's going, I'll upload it. So by the time this is over, that one should be out. But yeah, hopefully this makes sense. Oh, I forgot. There's a big rule I have to show you. This is actually really important. I'm so sorry. I meant to do this after. So let's say you are given, let's see, do I have, oh yeah, here we go. Cool. I have another example. I'll do another example really quick. I mean, I won't do the full thing, but unless you want me to. But I do have another example to show you that I confirmed with Jason earlier today. Do you want me to do this one, or do you want me to just... I don't know. I think you guys
You can
got
just
it.
do it.
Should I do it?
Super
Okay.
simple. Yeah, it's just an edge case, yeah.
Okay. All right. Let's go over this one real quick. So let's start off here. We need our R. Okay. We need our R. That's part of the question. So V plus A. So we have our V, which is 0. So we have 3. And then we're going to add our 1s to the 2. So we have a 4. And we're going to add a 4 to this column here, which is a 5. Okay. Now, the reason this is a special example is because you'll see here, you know, I'll just do it. So real quick, let's label these: process 1, process 2, process 3, 4, 5. 1, 2, 3, 4, 5. Okay. So if we see, let's go ahead and compare. It's requesting for 1, 2, 3. So 1, 2, 3. Is that less than or equal to 0, 2, 4? Well, we see here it's not, but we cannot say that this is deadlocked. And the reason is because if we go to the allocation matrix, we see that it's not taking any resources. Look, it's not taking a single resource allocated for this process. It may be requesting it, but it doesn't actually consume it. So what that means is that this is safe. This is a safe process. Okay? I know that's a curveball, and I know that is it's a little weird, and you have to now keep in mind this, but that's how it works. If it is 0, 0, 0, it is safe. Okay? That is not to say, I mean, it is to say if the Q is 000, it's probably safe. But keep in mind, if any A is 000, no matter what Q is, no matter what it's requesting, it's going to be safe. Okay? So we mark that as safe. And we don't update it. I mean, even if we did 000, it wouldn't do anything. So now we check. Let's go ahead and check 232. Let's check process 2. Okay. We check, is that less than or equal to 024? No, it's not. Is this 000? No, it's not. So this is deadlocked for now. Okay. We'll come back to it. Process 3. We have 100. Is that less than or equal to our 024? No, it's not. 1 is greater than 0. So it's deadlocked for now. We'll come back. Don't mind that spoiler. Let's go to process 3. We see 010. Is that less than or equal to 024? Yeah, it is. It is. We got 001104. So we could say that this is safe. Mark it as safe, And now we can update our new V. Our V is now equal to the allocation of process 4, which is 010. So now our new V is 1, 3. Or sorry, 03. Oh my god, I'm having an aneurysm. 034. Okay, there we go. Now, if we go look at process 5, I think I'm actually losing it. If we go to process 5, we see process 5 is requesting 231. 231. Is that less than or equal to our new V of 034? No, it's not. Therefore, that is also currently deadlocked. So we've gone through that, and we see, though, we've changed our V since last time we compared with 2 and 3. Now, you could use your eyeballs, and you could see that 0, 0, this hasn't changed at all. So we can still compare if you want, but you can kind of get the idea that at 034, when we go back and check these new processes, this is still requesting more, okay? Therefore, these are all confirmed deadlocks. So your deadlock is P2, P3, and P5. Oh, wait a minute. What is this? Look at that, 0, 0, 0. It almost got me. P5 is safe. Even though it's requesting more, the A is 0, 0, 0. Therefore, this has to be safe. See, it almost got me there. It's tricky. So P2 and P3 are deadlocked. Okay. And our final W is our final V is 034. Okay. Everybody got it? Any other questions? All right. Yeah, no. Yeah, P5 is safe. My bad. It is it is the aneurysm I was having. I think it's passed though. Yeah, we did test P2 and P3 again, but we see that 034, I mean, it's still requesting for P2, P3, 2 and 1, and for 034 there's nothing. So I mean, you do test it again. Keep testing it. I'm just being quick because I don't want to take up too much time. We still have a lot more to do, so I'm not going to test it. But you could see that it's not changing even after we change it. But yes, you do test it again. Okay. All right. If nobody has any questions, I'm gonna let the others present here. So last minute, anybody? If not, we're gonna be good to go. Yes, this was deadlock detection algorithm. You're welcome. I'm glad to help you guys.